Hello, everybody, and welcome back again. This is going to be our last section, or our last few sections, I should say, on Chapter 13 on wildfires. And we've looked so far at what makes fire go, what makes it work, and what it takes to put it out. Now we're going to be looking on some mitigation strategies or even prevention strategies with regards to wildfires. And this is kind of difficult to know how to do because, first of all, you cannot entirely prevent them. Even if we took the human element out of it, the whole careless human element of whether leaving campfires still burning or throwing glowing, cigarettes out the window and have it catch brush on fire, or even malicious intentions by humans like arson and that kind of thing. Even if we took all that out of the equation, they would still take place because, well, what causes a lot of large wildfires naturally? But lightning. And lightning you cannot prevent, and so these are going to take place. It's also a difficult problem to address because not all fires should be suppressed. Some should actually be allowed to burn. We'll talk a little bit later about why that is. All right, so how do we approach the problem of dealing or mitigating with wildfires? Well, first of all, science. All right, I mean, that's why we're learning this stuff. That's why we're talking about it right now, because it is a problem that does affect human beings and the environment in general. All right, we'll talk about that in a little more detail. Of course, education. Tell people, not just in terms of sitting in science classes and learning about wildfires, but educating the public. You've probably seen, I'm sure you have, posters or ads featuring Smokey the Bear. All right, Smokey the Bear is a wildfire icon that was started back in the 40s. All right, and then it really became kind of the face of wildfire prevention. So educating the public that way, collecting data. All right. This is really kind of linked to science right here because good science is based on good, solid data about where fires start and how often they occur and the recurrence intervals and that kind of thing. And finally, what we call prescribed burns. Now, this is one of our vocab terms right here. In many cases, it's also called controlled burns. Controlled burns. So that can mean, it can mean like your backyard bonfire, okay? So say your mom or dad are burning like extra cardboard or something like that, or extra wood. In many communities, that's actually not allowed, or you need to get a permit for it, okay? But the usage that we're going to talk about is not with regards to that, but what we really mean by controlled burns is controlled by professionals. That is ALS. That is, like, say, the fire company or other maybe forestry managers actually burn parts of the environment so as to make the big wildfire risk less. And like I said, we'll talk about that a little more in detail later as well. But controlled burns is another word for prescribed burns, and like I said, we'll define that a little bit later. Okay, so our first approach in a little more detail is, of course, science. All right, and that is collecting data, understanding how fires work and where they work. This word right here, or I should say this little phrase, fire regime. All right, this is one of our vocab terms actually, and what it does is it means the whole kind of fire likelihood of an ecosystem. All right, that means it takes into account, and this involves science, of course, the types of fuel that are available. All right. Let's say you've got an area that has a lot of dry twigs and sticks and maybe straw and that kind of thing. That would be a very different fire regime from, say, an area that was, we'll say, old growth oaks and maples and hardwoods and that kind of thing. Different kinds of fuel. So the type of fuel that is available, that dictates what the fire regime is going to be like. Okay? When fires do take place, fire regime is also defined by the behavior of the fire. How big is it? How intense is it? Does it burn quickly, or does it burn slow and long and hot? How much biomass is removed? All right, and this can happen repeatedly in certain areas, and it should. So, and in some cases, it should. So when it does, we can see how much mass is removed, and so we can add that to the kind of the description of the fire regime right there. And of course, like I mentioned before, as fires occur frequently, how frequently do they occur? This is one of our vocab terms as well, recurrence interval. All right, and that could mean fire. It could pertain to fires, or it could pertain to other things as well, like say earthquakes or volcanoes. But it simply means how long in between occurrences of fires does it actually take place. All three of these right here, all these elements contribute to what we call the fire regime. That you could call the fire regime kind of an overall description or an overall understanding of a likelihood of fire taking place in a certain area. All right, now science also involves what's called fire reconstruction. All right, and if you're very good at this, fire scientists can actually sort of reconstruct how and where fire started. They can, in many cases, can determine if it was started by a human or if it was started by lightning. Firefighters in houses, actually, even if a house is completely burned out, they can usually figure out how it started. Did it start at a certain electrical outlet, or did it start because the stove was left on? So fire reconstruction is a real science, and they've gotten it pretty dialed in. They're pretty accurate at figuring out how it started. So all these things are parts of the science of understanding how and why wildfires start. All right, I mentioned education already. All right, education being just educating the public in general, educating people. Now, obviously, you're sitting in seats right there. You're people that are being educated. But when we say educating people, we mean the public. All right, maybe somebody who never actually sat through a natural disasters class. All right, well, that's why we said, like I said before, we've got characters like Smokey the Bear. All right, Smokey the Bear. All right, and what's the famous phrase? Only you, ... only yo, only you, ... That's actually short for the fuller phrase, which is only you can prevent forest fires. So it is kind of addressing the public and saying that the public really does have control, at least over their own actions, and can help determine whether forest fires start or stop. Actually, it's interesting. Originally, it was only you can prevent forest fires. Okay. Recently, forest fires. Recently, it's been updated to say only you can prevent wildfires. Okay, because they don't have to involve forests. They can involve shrublands and chaparral and that kind of thing, kind of low-lying, dry, grassy areas. So this is kind of the updated version of the old Smokey the Bear saying, only you can prevent forest fires. Okay, data collection. Data collection we mentioned already, of course, but it's this is a great fire or wildfire prevention, or at least tool with regards to understanding how wildfires and forest fires take place. We have satellites. We do have satellites that can pick up infrared and can actually pick out where fires are taking place. And so satellites, but also remote ground-based sensing as well, can detect where fires are taking place. Mapping vegetation and potential fuel. All right. Vegetation tends to be kind of darkish, right? Now we think of it being kind of green. All right. So you have an area where you've got all kinds of trees and stuff. But if you look on a map, especially an infrared map, these areas with a lot of vegetation in it tend to be kind of dark. There's some trunks right there. Okay. So looking down on it from a satellite, these dark vegetation areas, they're dark because, well, green can be kind of a dark color, but they're dark because they are absorbing light. That is, trees are good at doing that because they grow from light, and they're giving off infrared. So in terms of light, we don't actually see the light reflected, but infrared is reflected. So what that means is that we can map vegetation using the kinds of, we can analyze the types of vegetation that are on the ground by the kinds of wavelengths they give back. And so we can map whole areas and determine what kind of vegetation exists there, and therefore we can know what kind of fuel is there on the ground. All right, now you can do it manually as well. You can just go through forests and figure out what kind of trees are they hardwood trees like oaks and maple? Are they pine trees with lots of sap? Are they like eucalyptus trees that have kinds of oils in them that can burn very quickly? So knowing the kind of vegetation that's there can help you determine your likelihood of a fire. Moisture content. Obviously, is it going to be dry? Is it going to be humid? Is it going to be wet? All right, that plays a big part into knowing whether a fire will take place. You're going to have much less likelihood of forest fires in Seattle than you may in Phoenix, Arizona, right? Because Phoenix, Arizona is much drier. So moisture content plays a big part. And finally, fire potential index maps. If you may have driven down the road and seen kind of a little, I don't know, it might be sort of like a dial like this, and it has a needle on it somewhere, and you've got different colored areas. So it might say something like, what's the fire likelihood today? All right, and over in blue it'll say low, or green it'll say, okay, a little bit higher, and orange it might say, these are supposed to be like wedges right there, or maybe it'll say red, very, very high. Okay, so these different colors, depending on where this needle is pointed for a certain day, they move it, it's moved manually, but it tells the public what the fire potential index is. Low, moderate, high, severe, etc. All right, well, these can also be made into maps as well. So you can find areas where you have the high or low fire potential index. And that's kind of let's say compiled by putting all these other bits of data together. Okay, and finally, prescribed burns. Like I said, prescribed burns are also known as controlled burns. All right, so that's that right there. And we don't mean somebody doing a controlled burn like in a 50-gallon drum in their backyard or in a bonfire, but we mean controlled burns by professionals. Intentional burns, not in a barrel or in a bonfire, but literally in forests. All right, and the purpose for that is to kind of, first of all, manage it very, very carefully so it doesn't get out of control. All right, and if you set a fire and you have the right tools, you can control it, and that's why we have to have a plan to do that. All right, but what controlled burns do is they eliminate a lot of the extra fuel that, let's say, a large forest fire. Well, maybe I can just illustrate it right here. All right, so say we've got a lot of trees right here. All right, and a lot of smaller fuel in between, and maybe even I'll put some brown in there. All right, some other kinds of medium growth trees in there. You get a lot of dense stuff. All right, right there is a lot of fuel all in one place. If you come through as a firefighter or maybe like a forestry ranger, and you intentionally burn out without letting the big stuff burn, if you burn out the smaller stuff right here, what you have then, I'm trying to change too many colors at once. If you can burn this stuff out, you have a bunch of trees that are more spread out, all right? And if one of those were to catch fire, let's say it got struck by lightning, if one of them were to catch fire, it's more likely to just burn by itself without catching everything else on fire in between. All right, so controlled burns, what they do is they manage forests by kind of cutting down on the extra growth fuel that could sustain a large fire. All right, what this also does is it allows new kinds of growth to come up if you kind of weed this stuff out by burning it. But it has to be done very, very carefully. All right, it just reduces the fuel for catastrophic fires while allowing the good fuel, that is the trees that we want there, to remain. So it's kind of like pruning your tree, I guess. You prune some of the not so good branches off so that the good branches can continue to grow. That's kind of a way of thinking about that. Okay, we're in the home stretch here. This is section 7. And we're going to be looking at now how people perceive wildfires and forest fires. And as with many natural disasters, most people are not adequately aware of the risk of forest fires or wildfires, especially in California. California, especially Southern California, is known to be very dry, and the risk of wildfire is ever present. All right, and yet people still develop homes on brush-covered hill slopes. Brush that is kind of low-lying, dry, maybe has certain kinds of oils in it, like eucalyptus, that burns very easily. Why do they build there? Well, because hill property is in very, very high demand. Everybody wants to be high up to be able to look out over everybody else. And so even if you've got a brush-covered hill slope that is ready to burn, development still takes place right there. All right, and people say, well, I'll just get insurance. All right, well, insurance can give people a false sense of security, especially if a wildfire is big enough. In some cases, catastrophes can be so big that insurance companies just have to say, hey, we just don't have the money. All right, and so we don't want that to be the case, but sometimes that does happen. Even so, do you really want to have to rely on insurance to replace your home? It may be a safety net, but you don't want to have that problem to begin with. Best practice is to not build where the wildfire risk is highest. All right, so how can we keep the public aware of the wildfire hazard? Well, of course, alerts. All right, daily changes in conditions is right here. All right, remember I drew that little kind of dial thing? When I drive to New Jersey to go to the Jersey Shore, we drive through. You may have done this as well. Through the Pine Barrens. All right, and the Pine Barrens can be kind of dryish. And as I go through the Pine Barrens, I oftentimes see one of those alerts right there. That every time you go through, the needle is on a different fire index setting. All right, so telling the public every single day what the likelihood of fire is one way to keep the public safe. All right, so all the stuff that is part of the fire regime, the fuel conditions, the topography, weather, risk of ignition, keep compiling all that data because every single day the fire risk is going to be different. And of course, red flag warnings. Remember I said when the needle was on the red, it means fire conditions are very extreme. These are extra warnings that are put out to alert the public that a wildfire is imminent. All right, it's either taking place right now or will take place probably in less than 24 hours because the conditions are so extreme that a wildfire is just about to start. Okay, fire education. Now, again, it doesn't mean going through a natural disasters class necessarily, but it means educating the public somehow. Smokey the Bear and all the posters and all the public service announcements can only go so far. They may help reduce the fire hazard, but even so, people see those things and they say, oh yeah, that's nice, yeah, we definitely should not make forest fires, we should definitely be careful, but without real experience, people don't take the necessary precautions, and that just may be human nature, but that's a fact, and that's the way humans operate. So we need to know that that's the case to really push the importance of managing wildfires or preventing wildfires. Okay, what else can we do? Well, fire codes and regulations. Remember I said before that in some places you can burn, trash or wood or paper or cardboard outside. Well, in many cases you can't, because in many cases there are bans on outdoor burning, especially during the summer when it's dry. This and also fireworks as well. In some places you can't shoot fireworks. I mean, you think, oh my goodness, what's more American than fireworks on the 4th of July? Well, it just so happens the 4th of July is one of the highest fire index months. And so when there are fireworks permitted, it's by trained professionals, and of course fire companies are always on hand if anything gets out of control or if embers start any kind of fire. But in many cases, the general public is banned from using fireworks, especially when the fire index is favorable. Building codes as well. I mean, if you want to buy or sell a house, you cannot buy or sell a house that that doesn't meet fire safety regulations. That goes for electrical, that goes for types of insulation. So certain fire-resistant materials must be in place if a house is to be approved to be bought or sold. You can get fire insurance, all right? So that means if you pay for fire insurance, then if your house is burned down, then you're going to be reimbursed for it, okay? But nobody really wants that inconvenience. We don't want our house to be burned down and have to be reimbursed. Best to just abide by the codes and not have the fire to begin with. All right, and let's say you're in the middle of the woods and a fire is approaching your house. Obviously, move away from it. We call that evacuation, right? So that's the most common adjustment to fires. It makes sure that you're safe, all right? So you're not going to die in the fire, but of course you can't evacuate your property, so that's going to be lost. That's where, of course, fire insurance comes in, but nobody wants, like I said, nobody wants that inconvenience anyway, so best to prevent the fires in the first place. The people that should be most concerned with this type of risk are people that live in the wildland-urban interface. All right, and that's one of our vocab terms as well, wildland-urban interface. And an interface is, I think I mentioned it in the last video too, it's where two different entities meet. Like if your hand is touching a desk, the interface is the space in between your hand and the desk. All right, or anything, where any two things come together and join. So where urban areas, that is where humans live, and where wildlands meet, that's a big risk for wildfires, because you've got a lot of fuel right here, and you've got a lot of clumsy people right here, and so if they're right next to each other, you have big risks for wildfires. All right, so especially people who live in these areas should be aware of the wildfire risk and obtain information to prepare for the inevitable wildfire. Okay, so at home right here, how can you reduce your risk of wildfire? Well, what I'm going to do is I'm going to zoom in on this a little bit and just kind of go through a few of them. Can I, let's see, I'm going to see if I can, maybe I can, oh, here we go, okay. There we are. Actually, again, it kind of gets sort of blurry, doesn't it? All right, well, home and heating systems. This is one of the big things that they check to make sure your home is up to fire code. All right, having a safety and evacuation plan. I would bet that a lot of people don't have that, but it's a plan that you actually put together as a family. All right, where do we go? And that involves things like smoke alarms. All right, now every house has to have smoke alarms, but I'll bet many people don't have an evacuation plan. And I'm not going to read all these off to you, but these are some things that you can do. Making your home fire resistant. All right, there are fire resistant and protective materials that you can use in your home. Certain types of insulation. All right, making sure debris is not around electrical areas or areas that could possibly catch on fire. Let me see if I can move up here. All right, and your landscape as well. All right, let your landscape defend your property. Grass can be a source of fuel, so make sure your grass is trimmed. Thinning trees. All right, making sure your trees aren't right up against your house, making sure that fuel isn't in contact with your house. So these are all some things that you can do to make sure your home is fire resistant. Okay, so with all these ideas and concepts in mind, let's go back and look at the two wildfires that were mentioned at the very beginning of the chapter. You had the Black Forest fire that was just a little bit south of Denver, Colorado, near I don't want to say Fort Collins, I want to say Colorado Springs, and also the wildfire in Arizona near Yarnell. That's the one that claimed the lives of 19 firefighters. So let's look at both of those for a second. Both of these kind of had some similarities, even though one had a much higher death toll. Both wildfires grew quickly, and they grew out of control, partly because the conditions were so right for the fires to take place. And two of these, these two were two of the worst ever to hit the region. And Colorado and Arizona are not exactly the same region, but it's generally the same area of the United States, kind of the mid-western, southwest United States. These were two big ones that really hit that area hard. Even so, with modern science and our understanding of wildfires, we really should not be surprised that these events are taking place. Droughts play a big role in whether or not forest fires are going to, or wildfires are going to take place. The longer the drought, especially in California right now, the likelihood of a wildfire really increases dramatically. As a result of wildfires, we can have an increase in flash flooding. We talked about flooding several chapters ago. All right, all because of the removal of vegetation, and that allows runoff to take place a lot faster. So flooding is one of the side effects or the other natural disasters that are linked to wildfires. Again, part of the reason for this increased risk is that is the development of so many wildlands right now, and that's maybe that just is inevitable. It's a natural result of humans living on the earth, developing wildlands. But we can manage that. Fire policy can dictate whether people can or cannot, or which wildlands people can build on, and that can help mitigate the likelihood of people being affected by wildfires. What's interesting is that since 1960, 6 of the most serious fire seasons occurred since then. Right? And we've got data going back into the 1800s, but the most serious fires have been relatively recently. And it could be a result of global warming or some other effect as well, but we definitely have seen an increase in fire seasons in recent decades. Some of the things that have contributed to this is the increase of biomass fuels. All right, things that are kind of breaking down and drying out, decaying things, that sort of thing. These have increased in recent decades as a result of the way we practice fire management. Pine trees, all right, they're great for harvesting, they're great for building with, but as we cut them down, what that does is that results in less, you might say, fire preventative materials in the forest. What that means is that very large pine trees, first of all, pine trees have kind of like a wax and a sap in them that can be somewhat fire preventative. But also, the larger the tree is, say for example, so I'll just draw a really tall pine tree right here. Okay. Well, the branches, the bigger the tree is, the branches grow further up. All right. So you may have a certain area of the trunk right here that has no branches on it. Well, that's a little more fire resistant because if you've got, I'll make this orange right here. You got a fire on the ground. That fire may not be able to reach the branches if the tree is big enough. Well, if you harvest the largest trees, then they're replaced by smaller trees that may be more susceptible to fires on the ground right there. Whenever we see fires, we tend to just suppress them and just put them right out. All right, and think, we dust our hands off and think that job well done. Well, the problem is that some of those fires we need to allow to burn because previously it reduced the amount of biomass available. If you put all those fires out, you preserve that biomass, which really leaves a door open for much larger, more catastrophic wildfires. Of course, higher temperatures, global warming, you may say, and drought are big contributors to wildfires, and also warmer winters as well. All right, so there's less snow in the winters, which means instead of snow, it rains, and the rain runs off, and so you don't have this reservoir of water in the snow. Rather, the water just runs off right away, and so the soil dries out more easily. So all those are factors that contribute to the really increased incidences of wildfires in recent decades. Okay, we're almost done here. So a couple more factors. Climate change, we talked about that already. It may or may not be a factor in any one fire, but it certainly contributes to the likelihood of fire on a wider basis. We mentioned how snow melt is occurring earlier as a result of climate change, leaving the ground drier and with less moisture, less of a water reservoir to keep the ground moist. As a result, the fire season has grown in length by at least 2 months in recent decades, so you've got likelihood of fire for longer periods of time. And humans continue to get in the way. As we continue to develop and build in wildlands, we have this likelihood of humans, first of all, starting fires, and secondly, humans being affected by fires. So as a result, we've got better evacuation and warning systems being developed, which is good in the case of Colorado because the authorities were able to get the word out and evacuate people quickly. In Arizona, people were evacuated. Unfortunately, some of the brave forest wildfire fighters who put their lives in harm's way were killed, but many of the residents were actually saved because of the fast thinking of the authorities. So the question is, should we let fires burn or should we put them out right away? It seems that putting out forest fires or wildfires right away would be a good thing, but it's possible that we should start letting fires burn so that we reduce the likelihood of even more catastrophic fires taking place because we're letting the fuel burn. So that's a problem we need to continue to look at and to try to solve, especially if you live in the West or Southwest. But that's going to be it for now for chapter 13. I'll thank you for following along. If you have any questions, make sure you come see me. Thanks, and I'll see you on the next one.